Hello class, I've been contacted by one of your classmates asking me to expand on the explanation for problems 10 and 12 for chapter 8, where you ask if you keep the same confidence level, do you increase the sample size, do you increase the confidence level. One main thing before I start all this that I put in here, I just took these values off from problems 6 to 12, where it tells you a mean, it takes a mean of 8.2 minutes for 200 people to complete a short form. The standard deviation, the variation is 2.2 minutes in 200 people. And then I asked you to calculate, or the problem asked you to calculate a 90% confidence level, and we got a confidence interval of 7.94 and 8.46. In summary, I told you that this table shows you the most common values for confidence levels that I already gives you the z-score to plug on your formulas to calculate your confidence intervals, so you don't have to go through all those calculations that I showed you yesterday. And pretty much here is telling you with a confidence level of 90%, we're 90% sure that if we encounter between 7.94 minutes to 8.46 minutes, this could truly represent the mean for our calculations, because our mean is included in this interval, and therefore it's confirming our results. I'm going to be showing you here what happens when you increase a sample size, what happens when you decrease a sample size, what happens when you decrease a confidence level, what happens when you increase a confidence level. Well, I think the most important thing is going to be for you to remember are these four rules right here. When you're answering a question, always think that as your sample size increases, as the sample size increases, the margin of error decreases. So it's I forgot the term now. One goes up, one goes down. So this is the relationship right here. What it means, if you remember, the more we collect, or in this case, the more people we survey, the more our values are gonna go right here, representing our normal distribution. The less people, as the sample size decrease, the margin of error increases. So the less people, so this value is actually going to go further and further from the mean. This is going to get wider. When the other way, the first one is going to get narrower. It's going to form a peak. Well, but if your confidence level decreases right here, if we go from a 90% to an 80%, for example, which is from 90% is 1.64 and for 80% is 1.28, as the confidence level decreases, the margin of error decreases. What does it mean? If you do remember the error bound margin formula, the z-value times the standard deviation divided by the square root of the sample. So let's put it over here. So instead of 90%, I have an 80% now. So we're going to do, I typed the values here so I could go back and refer to them instead of typing them. So for 80%, we have a 1.28 instead of my 1.645 for the 90%, right? And then I'm gonna do times my standard deviation, which was 2.2, and we're gonna keep the sample size as 200. So right here, we'll have about a 0.20. If you do remember from the other problem that we finished, the problem 6 to 12, says your error bound margin was 0.26. Do you see, as we decrease our confidence level from a 0.90% to a 0.80%, your margin of error, your error bound margin went down from 0.26 2.20. In the same way, if you increase, so if we increase from 90%, for example, trying to make, oh, the formula is open. If we increase from 90% to a 98%, for example, so if we go from 1.645 confidence level to a 2.33 times your standard deviation divided by the square root of the same sample size, you increase your margin of error. Okay, so they have a direct relationship, while the sample size and the margin of error, they have an inverted relationship. So right here you had a 0.26. As you increase the confidence level, I increased to 98% right here, you went up. As you decrease your confidence level, you went down. Okay, so just keep these rules in mind. Uh, if I ask you what happens if your size would increase, what happens if your confidence level would decrease, this would be the little rule. And that's what we're going to be showing right here. So now we're going to be calculating all this so you can see actually what happens. Apologize, I uh, got interrupted. So remember that right here, we calculate your confidence interval between 7.94 and 8.46 with a confidence level of 0.90. So then let's say that you ask yourself, what happens if my sample size decreases? What happens if my sample size decreases? Okay, so let's see what happens. Remember, we say that if your sample size increases, you represent more and more the normal distribution. So if you decrease your sample size, now we're gonna do the sample mean minus for the lower bound, doing this formula right here, my z-score, which is gonna remain 90% confidence interval, uh, multiplied by my standard deviation divided by the square root, my sample size. So let's see what happens if I decrease. Look how much further I went down my curve, way further. It got wider. Why? Because as the sample size decreases, the margin of error increases. You're giving more room for error. If you would do for the upper bound, you should expect also to increase this number to be higher, because now you decrease the sample size, so your margin of error is actually increasing. We're keeping I'm doing this formula right here, the upper sign, so it's plus the standard deviation, actually the z-score, which is the same one, confidence level 90%, so z-score 1.645, and then times my standard deviation divided by, and remember that we decreased the sample size, so we expected a higher number, and here we go. So now my confidence level went from 7.94 to 7.69, 7.69 to 8.71. So you increase your margin of error right here as you decrease your sample. Let's see what happens if you increase. Well, we say that if we increase your sample size, the margin of error decreases, correct? Actually, let me, you know what? Since I'm doing this order, I'm gonna put this over here. Since I'm doing this second, here we go. As the size increases, now I'm doing this one, the margin of error decreases. Let's see if that's true. We're gonna be having the same mean, which I could refer either here or here. So let's refer here. And then now I'm doing the lower bound, so minus. I'm keeping my same confidence level, multiplying by my standard deviation, correct? Divided by my square root. Well, now I increase my sample size. It really doesn't matter, and I'm sorry I'm confused you. You can pick it because the mean and the standard deviation remains the same. So it really doesn't matter which one you pick. The thing is, we're changing the sample size. That's the important part. So the square root of 400, okay, look, 8.02, it went higher because as my sample size increase, my margin of error decrease and gets closer to my mean. So let's do it on the other side. We have, let's just keep it here. Mean 8.2, and I'm doing the upper bound, so it's a plus. My z-score remains 0.90, correct? And then times my standard deviation divided by my square root. And then I increase my sample size over here, correct? Look what happened. Then now this got closer to the mean. So as my sample size increases, my margin of error decreases and then actually gets closer to the mean. Okay, so right here, your confidence interval is going to be 8.02 and 8.38. So now you have less room for error. Okay, now let's do where I want to decrease my confidence level. I put several here in case we need more or if you want to practice some. But let's go over here. Now we're gonna the confidence level decrease, the margin of error decreases. And I showed you why you have less or more error bound margin to deduct from your or to add to your mean. So here we go. Let's see if that's true. We're gonna keep the same mean, lower bound, so you subtract. And then now instead of a 90% confidence interval, I want an 80% confidence interval. I'm lowering, um, let me refer here. I'm lowering to my confidence level. So I should decrease my margin of error. So times my standard deviation and divided by the original sample size, 200. Here we go. It's a 8.00. See, it's actually better, still better than here. So, and then let's do the other side right now. We're gonna do equals to my mean and then upper bound, so plus or right side. We're doing this portion now of the curve, and then you decrease your confidence level, multiply by your standard deviation divided by the same square root. 8.40. See how it got better? So as the confidence level decrease, my margin of error decreased, therefore they get closer to the mean. Here you go, instead of a 7.94, now you have an 8, which is closer to the mean. And instead of 8.46, you have a 8.40, which is closer to the mean. So it's better. So you kept the same sample size and you decrease the confidence level to decrease your margin of error. So now let's increase your confidence level where your margin of error should, just misspell something here, correct? When the margin of error is going to increase. So let's go ahead and go over here and let's prove that. Okay, my mean, same thing. I'm doing the lower bound, the left side of the curve, negative, correct? You're tired of hearing me say that, but believe it or not, as we change the terms and everything, sometimes it's good to repeat until we finally, oh yeah, I know, left side negative, right side positive. I get it. Okay, but students tend to make mistakes when calculating then, so that's why I'm stressing so much. So minus my, well, I increase my confidence level to 98%, so it's at 2.33, correct? Times I'm keeping my standard deviation and I'm keeping my sample size as 200. Look what happens. What did I say? As the confidence level increase, the margin of error increases, therefore your margin of error increase, therefore it gets wider. So it's going to get further from your mean. And over here should be the same thing. This should actually increase. You're going to increase your confidence level, but you're keeping the same sample size. That's the problem. So let's go over here and do, just to prove, a mean. And then now the right side, the upper bound, and then we're going to increase the confidence level to 98% times your standard deviation divided by the square root of the same sample size. So look what happened. You went further down. You increased your confidence level, therefore you gave more room for error, and now the margin of error increased. And therefore your confidence interval would be between 7.84 and 8.56, which is actually much worse. You expect to be closer to the mean, which is much worse than at 90%. So let's see which one out of all this, really the worst case scenario is right here, where I kept my same error bound margin or my same confidence level, but I decreased my sample size. Look how much further you went from the mean. Okay, so which one will be my best? Well, my best, it's right here. This is my best because I kept the same confidence level. So in case of problems 10 and 12, I kept the same confidence level and I increased my sample size. Look at how much closer it got to the mean. So this would explain questions 10 and 12. This it's a little more clear for problems 10 and 12. So really it's a matter of, if you don't completely understand, the best thing for you to do is just to put several scenarios where you decrease the sample size, increase the sample size, and see what happens. Then you are able to answer, oh, okay, look, I decreased the sample size, I kept the same confidence level, therefore the same error bound margin, right? Actually, not the same margin of error. And look what happened. I decreased the sample size and I went further from the mean. I increased my margin of error. Right here, oh, look what happened. When I increase my sample size, I decrease my margin of error. Okay, so if you're not very clear, the best thing is to do a little table like this where you could visualize what's happening. I needed that a lot of times. I'm trying to explain, and it's, even for me, it's easier if I can look at it. For everybody, pretty much. Uh, it's just easier when you put in practice what you're talking about. And I hope this clarifies a little for confidence